Oh, well, everybody's heard about the bird. Bird, bird, bird. Bird's a word. Oh, well, a bird, bird, bird. Bird is a word. Oh, well, a bird, bird, bird. Well, a bird is a word. Oh, well, a bird, bird, bird. The bird's a word. Oh, well, a bird, bird, bird. Well, a bird is a word. Oh, well, a bird, bird. The bird's a word. Oh, well, a bird, bird, bird. The bird's a word. Oh, well, a bird, bird, bird. Well, a bird is a word. Oh, well, a bird, bird. The bird's a word. Oh, well, don't you know about the bird? Well, everybody knows that the bird is a word. Oh, well, a bird.
Today we're going to take a look at how earthquakes form, the types of waves that are generated by earthquakes, and how to use those waves to find an earthquake's epicenter. As always, I want you to take notes while you're watching this video. Today you're going to be taking them in your Topic 4 note packets. By now you should know that the Earth's plates are moving. When they move, they put the rock in those plates under a lot of stress and strain. That stress and strain causes a lot of energy to build up in the rock. Eventually, the rock can't hold that strain anymore, and the ground moves along a crack called a fault, and it releases all that energy in these waves. Those waves cause the ground to shake, and we get an earthquake. Whenever an earthquake occurs, we want to know where it started so we can study it. In this diagram, you can see that the earthquake is actually starting inside the Earth at a spot called the focus. An earthquake's focus is usually very deep inside the Earth, too deep for us to go to. The closest we can get to it is the spot right above it on the Earth's surface called the epicenter. And that's what we're going to learn how to find. Okay, let's write this down in our notes. A fault is a crack in the Earth's crust that allows the rock to move there. The focus is the spot inside the Earth where an earthquake starts. The epicenter is the spot on the Earth's surface closest to the focus. And an earthquake happens when the ground moves along a fault and releases stored up energy in waves. So there are several different types of waves that earthquakes generate. We're going to focus on two of them. The first is called a P wave. Now, P waves might not be what you would normally think of as a wave because they're more of a forward and backwards shaking. What's happening is the crust is being compressed and then stretched out. The other wave we'll look at is called an S wave. This is what you might normally think of as a wave because it has kind of that undulating up and down movement to it. This is called a shear wave. Let's go back to your notes. In this chart, we're going to compare these properties of P waves and S waves. So let's start with the P waves. The P in P wave actually stands for primary, which means it's the first one to get there. As far as the speed goes, compared to the S wave, the P wave is faster, which means it's the first one to arrive at a location. P waves can go through both solids and liquids inside the Earth. And as we just saw, the type of wave is called a compression wave, which means the crust is compressed and then expanded. Let's take a look at S waves now. The S in S wave stands for secondary, which means it's the second one to get there. Duh. The reason it's the second one to get there is because it is slower. So arrival is second. They can only go through solids inside the Earth. And then finally, the type of wave, again, is called a shear wave. So are you seeing a pattern yet with the properties of S waves? Here's a little trick to help you to remember them. They all start with the letter S. So S officially stands for secondary, but it could also stand for slower, second one to get there, solids only, and shear wave. Make sure you have these properties copied down in your notes before you proceed in this video. So if we could see these waves during an earthquake, they might look something like this. Remember, both the waves leave that focus at the same time, but the farther they go, the farther ahead the P wave gets because it's always faster than the S wave. So when these waves arrive at a location, we can use the time gap between the P wave and the S wave to figure out the distance to the epicenter. We'll learn that at another time. Now, besides moving through the crust, earthquake waves move through Earth's interior layers as well. So again, P waves and S waves leave the focus at the same time. P waves always faster. Watch what happens as these waves go down through the mantle and end up hitting the outer core. The P wave can go through the outer core, but watch what happens to the S wave. Once it gets to the outer core, it stops. Now remember, P waves can go through solids and liquids, but S waves can only go through solids. If S waves cannot go through the outer core, that must mean it is not solid. This is how we know the outer core is liquid. These waves behave differently. Because of this, an area called the shadow zone forms during an earthquake. So let's say an earthquake happens. P waves and S waves leave the focus at the same time, and they travel down through Earth's interior. Eventually, those waves come back out, and they are sensed in these regions, and we get a P wave followed by an S wave. But once those waves reach the outer core, their behavior changes. Remember, S waves can't go through the outer core, so they stop. P waves can go through liquids, but when they do, they get refracted, and they end up getting deflected away from these areas. And that becomes the shadow zone. This is an area that doesn't get any waves during an earthquake. The P waves eventually do come out on the other side, but they're not followed by S waves. Now, the only way for all this to happen is to have some type of liquid layer inside the Earth. So therefore, the outer core must be liquid. Okay, let's finish up the notes. The shadow zone gets no earthquake waves because the outer core is liquid. S waves can only go through solids, and they stop when they get to the outer core. P waves, on the other hand, are refracted or bent when they go through liquids, and therefore they're deflected away from the shadow zone.
Well, a bird is a word, well, a bird, 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 a word, well,